we are going to start to take each of the importance of or advantages of dimension analysis and look at examples right under them to prove that this is how they are used or that those importance are valid. Okay, so in this first session, we want to look at the finding the unit of a quantity, right? You want to use dimension analysis to find the unit of a quantity. So basically, what we are going to do is that when you have a dimensional analysis, right? When you have a quantity and that is expressed in its dimensional form, you can convert those things into the units. So you remember in the previous session what we're doing, we use velocity, right? We use the quantity. So velocity is equal to displacement over time. Then we try to find the dimensional analysis of that, dimensional value of that. You got L over T, and then L over T will give you L to T to the power negative 1, right? Now in this session, once you get the dimensional analysis, how do you convert back to its units? So let's look at a few examples. So now imagine that I said a particular quantity that you and I we don't know, right? Let's say the quantity is called capital A. So this is the quantity. And we say that the dimensional value of this, right? The dimensional expression of A is L T theta negative 1. Yeah, I know that we are going to use only M, L, and T, right? Mostly for our level. But remember that when we're introducing ourselves to the dimensional analysis of the basic quantities, we talk about theta being for temperature, right? In the standard unit of temperature, when we did unit, was Kelvin. So we are going to use that. So now, if this is the expression, then the dimensional expression of a quantity, right? What is going to be the actual unit? The actual unit. This is just the dimensional expression. We don't have the unit yet, so you have to get the unit out of that. So if you know the dimensional expression of a particular distance, we can convert it to what unit, right? So L is what? L is what? Length, right? It's for length. It's for separation. And then you know that anything that is length, right, is going to be like distance. And the unit of anything length is the standard unit of anything length is what? Meters, right? Now let's look at T. So if it's T, right, T is dimensional value of T, right? Everything that is T, meaning dealing with period, dealing with time, and anything that is time, the unit of a time is what? Seconds, right? So we are going to do that second, small s. And then theta, we say already, theta is what? Theta is temperature, and temperature is capital K, right? K is Kelvin, right? So now if you have that, then A is going to have what expression? A is going to have, so we have LT theta to the power negative 1. So L is what? Meter, right? T is what? So L is this. We say T is second. And theta is what? Capital K to the power negative 1. So this is going to be the unit of A. So the A has the unit, right? The unit of A is meter second Kelvin power negative 1 or meter second per Kelvin. Yeah, this is just an example of how to use that. Now let's look at another example. Let's say we have another quantity, let's say quantity B, and then it has the unit of L3 capital M squared T to the power negative 2. So now I'm going to just find this is the dimensional expression of that. So this is the dimensional expression of that. So now we are going to find the unit. So for the unit, you just focus on each at once, right? So the M, the L is what? Length. And length, the unit of length are what? Meters, right? So meters is going to be M to the power 3, right? The power is that they are the same. So capital M, M is what? Mass. M is anything that is mass. Every anything is mass, right? It's going to be in kilogram. So it's going to be kilogram squared, right? And T is what? T is going to be time, and anything time has the unit of seconds, so s to the power negative 2. So this is the unit from the dimensional expression of a particular unit of a particular quantity. So finding the dimensional analysis allow you to find the unit of quantity. So if you have a quantity you express in dimensional analysis expression, you can now use that, you can convert that back to the unit by referring to what they mean and the standard unit of those quantities that they actually stand for. Let me look at another expression, right? The common expression. You have L T to the power negative 2. We've seen this thing before, right? This is going to be what? Acceleration, right? But now let's confirm. Let's confirm that this is actually, so this is the dimensional expression of that. So we are going to find the unit of this. So, and this is acceleration, right? Let's confirm if it's acceleration. M is what? L is length, right? Anything length is going to be meters. Meters. Small m meters. Now, time is capital T, and capital T is what? S, because T is seconds or time, and anything, the unit of time is seconds, and seconds is going to be small s, and the power will come to this one. So meter per second squared, meters per second squared. This is definitely acceleration. Yeah, this is definitely acceleration. So that's what dimension analysis. So let's look at another example. This one is going to be weird example, right? I'm just going to combine things like I want. So I have I. Remember how I is, right? I. Yeah, we are supposed to do M, L, and T. That's what you have to know. But I want to test if you actually understand that we have the seven basic quantities and their dimensional expression. I is current. Do you remember? So yeah, I was for current. And I'm going to use L to the power negative 3, capital M, and T. I'm going to use theta power negative 2. This one is just to test that we understand how to convert. So this is the dimensional expression. For dimensional expression, they are always in square bracket, right? Now, so this is also supposed to be in, so that whenever you put that, meaning you are going to, but right now we are going to fetch only the unit. And I is what? Current. And it is current, right? The standard unit of current is ampere. And an ampere is, the symbol is capital A. And L is meters, right? So it's going to be M power negative 3, right? And M is what? M is kilogram because it's mass. Anything mass is, the unit is kilogram, and T is second, right? So second, and theta is what? Kelvin because it's temperature. So capital K to the power negative 2. Yeah, so it's weird. I don't know the unit of this, but then the exercise is to actually show you how to use the dimension analysis to find the unit of a quantity. Yes, so basically that's what we do. That's the focus on this particular session. So yes, so dimension analysis, this is how it is important. Once you convert something to dimensional, its dimensional value, you can easily use that, convert those things to link them to the actual units of those quantities. Yes, so this is the first example of dimension analysis. This is the first importance of dimension analysis. We hope that you stay with us and continue with the next session where we explore the other importance, solving examples under each of them. See you in the next session.